Recently, our client John met his banker to discuss plans for a clean energy building. What he found was a shared passion for building something more, momentum for change. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. A lifetime of hard work, children laughing in the kitchen, family photos on a restaurant wall, a legacy that lives on. It all comes from the power of a conversation, like the one Tommy Hall had with First Horizon Bank about taking over his father's Charleston-based restaurant business. Now the table is set for a whole new generation. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Tommy. First Horizon Bank, member FDIC.
This is SpaceTime, Series 26, Episode 57, for broadcast on the 12th of May, 2023. Coming up on SpaceTime, the star that breaks the laws of physics, lightning bolts create a strange, never-before-seen mineral, and a new hypothesis on how Saturn got its glorious rings. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers think they may finally have worked out why a distant neutron star Pulsar appears to be breaking the laws of physics. The star M82X2 is an X-ray pulsar located in the galaxy Messier 82, approximately 12 million light-years away. The thing is, it's exceptionally luminous, radiating energy equivalent to approximately 10 million suns, and that is 100 times brighter than it should be based on the laws of physics as described by the Eddington limit. Stars this luminous are referred to as ultra-luminous X-ray sources. And M82X2 recently blew the laws of physics apart by exceeding its limit by up to 500 times, according to new observations by NASA's New Star Nuclear Spectroscopic Telescope Array spacecraft, which have been reported in the Astrophysical Journal. The problem we have is that stars only exist because they manage to achieve hydrostatic equilibrium. That is the very unique balancing act between radiation pushing out from the center of the star and gravity pressing inwards. The Eddington limit describes the upper limit of brightness that a star of a given mass should be able to have. Any more, and it would end up either imploding or exploding. It all comes about because photons exert a small amount of force on any objects they encounter. Now, if a star emits enough photons per square meter, then the outwards push of photons can overwhelm the inwards pull of the object's gravity. When this happens, an object's reached the Eddington limit, and the light from the object would theoretically push away any gas or other material falling towards it. But M82X2 has clearly blown that limit out of the water. It's part of a binary star system. Now, assuming the neutron star pulsar in this system is of average size, it would have around 1.4 solar masses, and the companion star would be around 5.2 solar masses in size. We know M82X2 rotates every 1.37 seconds, and it revolves around its more massive companion every 2.5 Earth days. Now, previous theories suggested that the extreme brightness being brought out by M82X2 could be some sort of optical illusion. That idea suggested that strong winds were forming in a hollow cone around the light source and concentrating most of the emissions in just one direction. And if that direction just happens to be pointed directly at Earth, the cone could create a sort of optical illusion, making it falsely appear as though the star was exceeding its brightness limit. Trouble is, the new research by NASA's New Star shows that's simply not the case. M82X2 is actually breaking the Eddington limit. The new study's taken a different approach. It looks at how M82X2 is interacting with its surroundings. The study suggests that M82X2 is consuming around 9 billion trillion tons, or roughly 1.5 Earth masses worth of material each year, sifted from its binary companion. Now, when this material hits the neutron star's surface, it can generate the off-the-chart brightness being observed. Astronomers think that the intense magnetic field of the neutron star is somehow changing the physical shape of its atoms, thereby allowing the star to stay together and, well, from our point of view, breaking the laws of physics. This is SpaceTime. Still to come, a lightning bolt creates a strange, never-before-seen mineral in Florida. And we look at a new hypothesis to try and explain how Saturn got its spectacular ring system. All that and more still to come on SpaceTime.
This morning in North Carolina, wheels are spinning. Determination is winning. A passion is now a thriving business, and it shows no signs of slowing down. How? The power of a conversation, like the one Clint Spiegel had with First Horizon Bank about starting a bike wheel manufacturing facility in Asheville. Now it's not just talk, it's rubber meets road. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint. First Horizon Bank, member FDIC.
A lightning bolt which struck the ground in Florida has created a strange, never-before-seen phosphorus material. Geoscientist Matthew Pasek from the University of South Florida says the strange rock might represent a member of a new mineral group. He says this mineral has never been seen naturally before on Earth, although similar but not identical minerals have been identified in meteorites. When lightning strikes a tree, the ground typically explodes out and the surrounding grass dies, forming a scar and sending electric discharge through nearby rocks, soil and sand, in the process forming fulgurites, also known as fossilized lightning. Well, recently, when a local Florida homeowner discovered the lightning scar in his yard, he found the fulgurite and sold it to Pasek. Pasek and colleagues then began studying this unusual calcium phosphate-based rock in order to better understand what happened for the lightning to form the mineral. Pasek says it's important to understand how much energy lightning has and the sort of damage it can cause. In wet environments, such as in Florida, iron will often accumulate and encrust tree roots. In this case, not only did the lightning strike combust the iron on the tree roots, but it also combusted the naturally occurring carbon in the tree as well. And these two elements led to a chemical reaction which created a fulgurite metal glob. Inside the fulgurite, a colourful crystal-like matter revealed a material never before discovered. Now, the authors have failed to be able to reproduce this mineral in the lab. That suggests that it likely formed very quickly under very precise conditions. And if heated too long, it simply turns into the mineral found in meteorites. The lightning reduction of phosphate is believed to have been a widespread phenomenon of the early Earth. However, there's an environmental phosphate reservoir issue in Earth that these solid phosphate materials are hard to restore. This research may reveal other forms of reduced minerals are plausible, and many could have been important in the development of life on Earth. The findings have been reported in the journal Communications, Earth and Environment. This is SpaceTime. Still to come, a new hypothesis tries to explain how Saturn got its rings, and later in the science report, devastating news for medical science, with researchers finding a link between opioid-based drugs and cancer. All that and more still to come on SpaceTime. A new hypothesis suggests that Saturn's spectacular ring system could be a mere 1 to 200 million years old. The idea, reported in the journal Science, proposes that the elegant rings were created by the destruction of a tiny ice moon, ripped to pieces by gravitational tidal forces after passing beyond Saturn's Roche limit. A Roche limit is the point in space out from, well, say a planet, where the planet's gravitational pull on the near side of an orbiting body is significantly greater than the gravitational pull on the far side of that object, causing the object to literally be ripped apart. The new scenario by Jack Wisdom and colleagues from MIT, the Massachusetts Institute of Technology, could explain not just Saturn's stunning rings, but also its axial tilt and the somewhat elongated orbit of the planet's largest moon, Titan. Wisdom and colleagues say Saturn's precession, that is the slow wobble of its spin axis, has almost but not quite the same period as the precession of the orbit of Neptune. The researchers thus suggest that there may once have been a true spin-orbit resonance between the two planets, and the relatively rapidly drifting away Saturnian moon Titan, which currently spirals outwards from Saturn at about 11 centimeters per year, might have lowered Saturn's axial precession period until the resonance locked in hundreds of millions of years ago. That's when Saturn's spin axis started to tilt, possibly by up to 36 degrees according to the team's calculations. The authors say Saturn escaped the spin-orbit resonance with Neptune because it once had an additional moon orbiting between the orbits of Titan and Lapidus. When Titan drifted outwards, this moon, which they've named Chrysalis, became trapped in a 3-1 resonance with Titan, orbiting Saturn once for every 3 Titan orbits. However, computer simulations showed that this resonance wouldn't have lasted, and Chrysalis's orbit would have become chaotic, with the moon experiencing a couple of close encounters with both Titan and Lapidus before either being ejected out of the Saturnian system or ending up so close to the gas giant that it crossed its Roche limit and was torn apart by tidal forces. The elimination of an icy moon about as massive as Lapidus would suddenly change Saturn's precession period, rescuing it from its spin-orbit resonance with Neptune. They say Saturn's axial tilt would also have started to decrease, eventually reaching its present-day 26.7 degrees. The authors say the earlier close encounters with Titan may also explain the giant moon's relatively high orbital eccentricity. And if Chrysalis was indeed ripped apart, then Saturn's impressive ring system may be part of its icy remains. The simulations suggest that the cataclysmic destruction of this planetary moon probably happened about 100 to 200 million years ago. And that fits in nicely with the relatively young age that many researchers had previously suggested for Saturn's rings. That age is based on the idea that the rings are really bright, even though impacts from micrometeoroids, interplanetary dust, and cosmic rays should darken the rings over time. Jonathan Nally, the editor of Australian Sky and Telescope magazine, says it's a fascinating hypothesis.
Stuart, Saturn's rings, as you say, are really, really beautiful, really pretty. There's nothing like seeing Saturn through a telescope, and you look at these rings and you think, wow, you know. And when you look at them, they look big and substantial, but they're actually really thin. They're spread out a long way, but if you saw them side on, they're actually really thin. And there's long been a debate about the origin of these rings. Where did they come from? Why are they there? How did they form? And basically it boils down to 2 options. One is that they were formed when a moon of Saturn disintegrated and all the material then spread out in orbit around the planet in sort of a thin ring or multiple rings, just sort of going around the middle of the planet. The other idea is that they were formed when material that would normally have gone to make up a moon was prevented from doing so by sort of gravitational effects, tidal effects between Saturn and some of its other moons, perhaps. And so this material couldn't form into a moon and then sort of spread its way around the planet, form these nice rings. So they've been the 2 main ideas for years and years and years. Now, there's a new twist on the destroyed moon idea. So some astronomers have proposed that Saturn might once have had an extra moon, which they've called Chrysalis, just a name they've come up with, that had what they call some close orbital encounters with 2 of Saturn's other moons, Titan and Iapetus. Now, these close encounters might have pushed this hypothetical moon, Chrysalis, too close to Saturn, where tidal forces then tore it apart. Yeah, if you get to, it's a sort of for any planet, there's a distance from it where if you hang around the distance too long, if you're a moon, you might end up disintegrating. So that could have happened here, and the resulting debris from this disintegrated moon would have spread out to form the rings. And they suggest that this might have happened about 100 million to 200 million years ago. That would match what other astronomers think is actually the likely age of the rings. Part of the debate about the rings is how old are they? Have they been around for a long, long time in space terms, or are they fairly new in space terms? 100 million to 200 million years ago is fairly new in space terms. And one of the reasons that's been suggested is that the rings are nice and bright. They're very shiny. They reflect a lot of light, and some astronomers, or many astronomers, think that the older a ring system like that would get, the rings would become darker.
Yeah, if you look at all the other
sort of chemical effects.
Yeah, if you look at all the other gas giants in our solar system, they all have dark ring systems.
Darker ring systems, yeah. So that's the sort of young ring hypothesis, that they look nice and shiny and bright and new in sort of space terms, space age. That could be right. That could be right. Now, if this moon had been there and it disintegrated and everything, then it would have changed. Disintegration of the moon would have changed what you might call the dynamics of the overall Saturn system, resulting from the moon's destruction, and it would have actually changed Saturn's axial tilt, which sort of matches what they see. And it would also have changed Titan's orbit as well, because you would then sort of removing the gravitational influence of that moon, or spreading it out, if the destroyed moon then sort of became the ring. So that's what they're suggesting. Now, not everyone agrees with this overall concept, because it sort of does hinge on this moon destruction event matching the suggested age of the rings. And not everyone does agree with this whole idea that the rings are only 100 million to 200 million years old, because they're nice and shiny and bright. So it remains an interesting but unverified hypothesis for now, but it's one of those, I guess it's one of those things we're not going to solve, I don't think. At least I can't really see how. The only way I think we could ever solve this is if we get telescopes that are really good enough, big space telescopes perhaps, to be able to see this sort of thing happening in another planetary system out there in space, perhaps a nearby one. If we can get telescopes that are good enough to see, even in very basic or rough form, a moon or even a planet circling a star being ripped apart and then spreading out, that would sort of give us a good verification that this sort of thing happens. And then whether it happened in the case of Saturn to form the rings, who knows? But anyway, it's interesting stuff.
It's expected to happen to Phobos around Mars in about, 20,000 years? Just got to wait.
That is true. That is true. So Mars has these two small potato-shaped rocky moons, and Phobos is sort of, well, in space-time terms, is not long for this world or for that world, and could get ripped apart and form a ring around the planet. And it probably even happened to Earth in the past, So it could be a very common thing. It's just that, or at least a common thing over the enormous periods of time that we're talking about in the history of the universe. So you sort of have to be lucky to spot one that's either happening or just happened. When I say just happened in inverted commas, only a few 100 million years ago. So the more sort of examples and samples you have of what's happening with planets and rings and things, the better you can get an idea about it. Which is really why it's great to live in this era of the world, when we're discovering all these planets circling other stars and getting better and better data, and hopefully better and better pictures as the years go by. And we might see more and more of these things in the process of happening, or having just happened, or about to happen. So it's all grist for the mill.
That's Jonathan Nally, the editor of Australian Sky and Telescope magazine. And this is SpaceTime.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
And time now to take another brief look at some of the other stories making news in science this week with a science report. Scientists have found a link between opioid-based drugs and cancer. A report in the Journal of the Royal Society Open Biology reviewing existing research found evidence of a link between taking drugs derived from opium, which include opioid painkillers, morphine and codeine, and an increased risk of developing various types of cancer. The results are raising concerns about the safety of these common pain drugs, which are often used to relieve pain in cancer patients. The thing is, opium derivatives have been found to have both tumour progression as well as tumour inhibition effects, making it difficult to determine their overall impact on cancer development and progression. The potential link between opium derivative use and cancer development is an important topic given the widespread use of opioids for pain management. A new study says healthy low-fat diets as well as some low-carb diets could prolong the lives of middle-aged and older adults. However, the findings, reported in the Journal of Internal Medicine, also warned that unhealthy low-carb diets could do the opposite. Now, this was a decent-sized study. It looked at over 370,000 people between the ages of 5 and 71 over a period of 23 years. They found that eating a healthy low-fat diet with lots of plant protein and high-quality carbs was related to fewer deaths from all causes, including cardiovascular disease and cancers. But in contrast, unhealthy low-carb diet were associated with significantly higher total cardiovascular and cancer mortality rates. A new study warns that climate change may have already pushed parts of the Amazon forest to their limit. The findings, reported in the journal Nature, assessed 129 tree species across the Amazon to see how capable they were at managing water stress amid growing droughts. The authors found that species vary greatly in how well they can handle water stress, with some forests in the western and southern Amazon potentially already at their limit. Now, given the role the Amazon plays as a carbon sink, the researchers say this could be a major threat as the climate continues to change. There's been another round of Scare Me If You Can Facebook videos warning of the perceived dangers of 5G cell phone towers and the levels of radiation they're alleged to be pumping out. Tim Mendham from Australian Skeptics says, like all the others, this latest video is wrong and simply doesn't employ good science.
The claim has been around in websites for a while, or was shared quite a lot on the net, as these things do, that basically that you're exposed to more radiation from being near a 5G tower, 5G communications, telecommunications tower, than being inside a microwave oven. They're suggesting that if you use a little meter that's sort of supposed to sort of measure what's going on, the energy output, you can prove that the energy output from the 5G is worse, more dangerous than a microwave. Now, a fellow who did this put up a video showing that he was holding up what's called a tri-field EMF reader, electromagnetic frequency reader, and he held it beside the microwave, which is stupid because the microwave oven shields the radiation from getting out, and so therefore the measurement you're doing outside the microwave oven is nothing like the reading you get inside. And then he went to a window and pointed it towards the 5G tower. It might have been a long way away, and did his measurement again. And what they're pointing out was that measurement, you're probably not even getting a good reading of a 5G tower if you're such a distance away staring out the window. The actual output, if you go and do a proper measurement of a 5G tower and a microwave within a microwave oven, the oven is 150,000 times stronger than is a 5G. So the whole claim is just complete bonkers. There is no truth in it at all. In fact, 5G towers are probably less dangerous than other forms of communications, telecommunications, and they're quite weak. But this particular video, which is fact-checked in the media, says it's absolute garbage. That's what's being portrayed. Nonetheless, it's been copied, 600,000 views, etc. So people will believe anything.
A lie travels around the world before the truth can put its boots on.
That's right. I always thought it was trousers on, but never mind.
Well, this is a family program, so we assume they're already wearing trousers.
Anyway, so if you fact-check this video that's around and you look at it, you have to say, are the claims accurate? No. In fact, they're so inaccurate that it's just ludicrous.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Wells Fargo presents one of the surest ways to grow your money, a Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.